The most efficient energy is the energy we don't use, the electricity we don't generate, we don't transmit, we don't consume. Operational efficiency is about doing more with less, better outcomes with less energy, less cost, less carbon. My name is Lincoln Bleveans, and I run Sustainability, Utilities, and Infrastructure here at Stanford University. I am so excited about the climate tech map and the opportunities it holds. I'm working in operational efficiency because I see an absolutely massive long-term opportunity to do good and do well, to make the world a better place, but also prosper economically. More broadly, though, the most efficient energy is the energy we don't use, the electricity we don't generate, we don't transmit, we don't consume. Operational efficiency is about doing more with less, better outcomes with less energy, less cost, less carbon. We need innovation in this area because our world is changing fundamentally. Temperatures are getting hotter during the summer. We have a massive influx of people into cities. In fact, we're about 55% urbanized now as a planet, and we will be nearly 70% urbanized by 2050. That's 2.5 billion more people in cities, and those people will need to be cooled. A lot of them will be buying their first air conditioners, their first electrical appliances, perhaps their first electric vehicle. Even more importantly, the role of air conditioning changes fundamentally as the climate gets hotter. Air conditioning goes from a comfort tool to a survival tool in many parts of the world. As a result, the energy-efficient buildings industry is projected to grow from about $150 billion now to $250 billion just in the next decade. There are so many innovation imperatives in this area. For example, high-efficiency HVAC systems, more cost-efficient, more carbon-efficient ways to heat and cool our buildings. Think of the innovation imperative of smart electrical appliances, whether it be an electric stove or an electric vehicle. By increasing product ranges, usability, and the appeal of these devices, we can cut significant amounts of energy out of the system, which has both a big cost benefit and a big carbon benefit. One innovation imperative is citywide district heating and cooling. So in many places around the world, individual buildings are responsible for their own heating and cooling. Imagine a skyscraper with very large air conditioning units on the roof, for example. A much more efficient way to do it, and the way we do it here at Stanford, is something called district energy, where we have a facility that produces hot water and chilled water that is then piped out through the campus and into the buildings, providing a centralized source of heating and cooling that is far more cost efficient and far more carbon efficient than leaving each building to provide for its own heating and cooling needs. Well, I would first provide a tremendous amount of encouragement because there is so much opportunity to do really substantial, really impactful work in this area. I would start with data fluency. Be fluent in data, the way it's created, the way it's processed, the way it's used. I would tack on AI literacy at a minimum. Strong AI skills are already incredibly important. And then finally, I would fall in love with systems. We're talking about a couple of different kinds of systems. There's the HVAC system within the building that provides heating, ventilation, and air conditioning, but there are also the human systems. How do people use that building? What do they need to be comfortable and productive in that environment. Falling in love with systems, really digging into how things work in the real world, is absolutely imperative in terms of solving these real-world problems that we have. I would encourage everyone to look at buildings through new and smarter eyes. Look at the way they're constructed. Look at how people use those buildings. And think about the systems that operate those buildings and how those might be optimized for user experience, how they might be optimized for cost, for carbon, how AI might be able to do things more efficiently within those systems. There is so much possibility, and I encourage everyone to look at buildings as an opportunity and a partner in decarbonization, as opposed to just another part of the landscape.